Hi, today we're going to go through a comprehensive course on the data wrangling process using Dplyr and Tidyr. So if you're only looking for a particular function of Dplyr and Tidyr, hover over the video line at the bottom to find the chapter of the video that you want to see. Otherwise, we're going to start from the top. So if you're new from this package and new to it, you need to install Dplyr and Tidyr and subsequently load them in your library. So if this is the first time you've done this, you type in install.packages, type in Dplyr in quotes, or if you see it pop up as such, you can hit the tab button to select it and it'll autofill. You'll also want to install the package Tidyr, but this doesn't mean you have it loaded into your system to actively use. So like a book on a bookshelf in a library and you want to read what's there, you need to pull it off the shelf. So we're going to use the library function to pull Dplyr off that metaphorical shelf and allow us to use it actively through this course. So library Dplyr, again, it can autofill. And then again, library Tidyr. So these are the two that we're going to be running through today. And once you have these installed and loaded, we can begin with some basic syntax within Dplyr and Tidyr. Specifically, we'll be using the iris package, which is publicly available for you to follow along with. So let's begin. I'm going to be basing this course off of the Dplyr cheat sheet, which I will link in the description below as a PDF. So that way, once you are finished, you can return to it and practice with your own data from your own research. But to begin, I'm just going to go through the very fundamentals of this. So if you type in TBL_DF, and then in the parentheses, type iris, it's a function that converts data to a table class. And tables are easier to examine than data frames, and R displays only the data that fits onto the screen. So if we run this line and scroll down to the end of our script, we can see that it has loaded what is able to fit within the screen. So here we see the table for the data set iris, sepal length, sepal width, petal length, petal width, species. However, there is more to this data sheet. So if you click on the numbers below, you can start to see that the data continues to show all the measurements that are in this data set that we will be walking through. So don't be nervous if you know there's more to it and you're only seeing a small amount of the data below. Just go to the next page of that data. The next line that we're going to run is similar, but rather than putting the output at the end of our script, it's going to go down in the console below, and you can see that it's already there, but we're going to run it again just to cover our bases. So glimpse does what you think it does. It's an information dense summary of the table data. So you're getting a glimpse of iris below, and you can see that there are 150 rows, 5 columns. So we have sepal length, width, and species. So as we had just seen here, or previously with the table data frame, you have similar measurements shown. Just a different way of taking a look at your data. Now, the third way that will pop the data frame up above is view. So maybe you want to view it in its own tab like it was an Excel sheet, or perhaps you inputted and imported an Excel data sheet and you want to see it. You can do view and then your data, in this case iris. So this allows you to view the data set in a spreadsheet like display as such. So again, 1, 2, 3, 4, 5 columns and 150 rows. that is what we've seen the previous two lines. This is just a third way of being able to look at your data comprehensively. And I would say this is probably the most frequent way you will look and interact with your data in R. Next, we're going to briefly touch on what is called piping. Now, I commented this out. So if you use the pound symbol, you're able to type comments without it interacting or interfering with your script. So pipes are the %, the greater than sign, and a percentage. These three keys right here. So this passes an object on the left side as the first argument of the function on the right side. So for example, x piped into f of y is the same as if you just typed f x comma y. Another example is if you did y and then piped it into f of x comma dot comma z, it's the same as if you did f of x y z. So it more or less pipes and inserts it into that blank space. So again, this is called pipe, and piping with this makes your code more readable. And here's the example using the iris data set. Iris, you pipe it, and you want to group by species, and we're piping the group by species into the summarize function, in which we're typing in, we want the average equaling the mean of sepal width. And then we're going to arrange it by its average. So we're going to basically see it high to low. So you can connect multiple pipes into your script. And that's what you see here. So starting with iris, we're looking into, we're going to first group it by species. Then we're going to summarize that by specifically looking at the mean of our sepal width. And then we're going to, from that point, arrange our averages. So let's run this. And what we can see below, so we have 3 rows, versicolor, virginica, and setosa. We have their average sepal width listed here. Now, why are there only 3 rows and 2 columns? Well, if we look at our iris data set, we have setosa, versicolor, and virginica. We only have 3 species in this 150 row data set, and we average the sepal width. So it's taking the average of all under virginica, and then also taking the average of all under versicolor, and then thirdly taking all of the average of the sepal width in setosa. And here is its summary. Very simple, condensed way of looking at your data in a fast pace. So that's piping in a very brief nutshell using Tidyr and Dplyr. This is a very powerful method, and you can find much more complex ways to use pipes, but this is where we're starting today. We're going to pause here. If you need to work through these first steps, I encourage you to go back, do it again. And if you're learning R for the first time, work on typing every bit of code out rather than copying and pasting. It is tedious, but you will learn what the code is really doing faster, and you are likely to catch mistakes earlier. If you copy and paste, there's simple little syntax errors that can occur very fast. So if you type everything out, you will catch those mistakes sooner, which will prevent headaches down the line. All right, we're going to pause here, and we'll continue on with subsetting in a moment. Okay, now we're going to move on to subsetting observations or rows using the iris data set, and then we'll also move into storms, but we'll touch on that in a moment. So if you want to extract rows that meet certain criteria, you want to use the filter function. So filter, we're filtering the dataset iris by sepal length And then this is where we set the criteria. It can say greater than, it can say less than, it can say equal to, so you can be as precise as you want. In this case, we're using 7. We'll do a couple here. So filter, type along with me, iris. Don't forget to capitalize because in the data sheet, this is capitalized and capitalization matters here. Let's say equal to 4. And then we'll do filter, iris, sepal length less than 7. So if we run all 3 of these, we do see we get an error, but that's likely because there's no sepal length that's equal to 4 exactly, which is fine here. But if you know that your data has exact criteria to meet, you can use the equal function. But for filter sepal length greater than 7, when we go down below, we can see all the sepal length data based on species that is greater than 7. Now, if we go back up and do less than 7, we will see all the sepal lengths that are less than 7. So this is a really good way to just subset your data quickly and effectively based on criteria that you want to set up for the parameters of your own data. All right, let's move forward. Now, if you want to remove duplicate rows, use the distinct function. So if you have a lot of duplicates and you want to just understand the individual aspects of it, we get rid of duplicate rows by using distinct. So distinct iris. We go down below, we'll see that we only have unique data pieces here. No two should be alike. Moving forward, if you want to randomly select a fraction of rows, use sample frac. I'm going to zoom this out a little bit. There we go. We're going to use sample frac or sample fraction to randomly select a fraction of rows. So sample frac, iris data set, 0.5, and replace if true. So that's the criteria you need to meet. There you have it. All right. If you want to select a specific row by position, use slice. So slice, iris, and then rows 10 to 15. We will now see that we only have 1, 2, 3, 4, 5, 6. So 10, 11, 12, 13, 14, 15. That's 6 rows total. And that's what the criteria have met. We're going to dive further into the slice function now, because on this cheat sheet that I have attached below, top n is listed as the next item on the cheat sheet, but it no longer works. It's been superseded by the slice function in its entirety. So while the cheat sheet I attached shows top n as an option, I'll be showing you the slice function. And to troubleshoot this function later, as it's not listed in the cheat sheet, I will attach a link in the description to provide a detailed explanation for the slice function. So let's begin. We'll be using the data frame storms for this function. So just to show you what that looks like, it's different than iris. You guessed it, it's based on storm data. It's quite a large data set. We're only looking at rows 1 to 20 of 10,010 entries. So this is a very large data set. And what we're going to go through is going to be showing you the power of the slice function in R. So say you have all this data. I've had data sheets that have 45,000 rows, and maybe you want to know the top 10 of your data In this case, maybe we want to know the top 10 storms based on certain criteria we've set up. In this case, we're going to look at in terms of wind speed. Since we're looking for the top 10, we're going to use the slice max function as such. So slice max storms, comma, the number of storms that we want listed in the output is 10. We want to order it by wind. You can choose a different column if you want. Go for it. Function will remain the same. You can, if you only want to look at the top 5 or the top 100, you can list that number here under N. So if we see below, we have 1 to 10 of 21 rows, because I'm sure there's some overlapping duplicates here in the top 10. So we can see the name, the year, and the wind speed, and the status of the storm. So it's organized our data based on the criteria we've set up around wind. Now let's look at the bottom 10 storms in terms of wind speed using slice min. So keep roughly this remainder the same. We're just changing slice max to slice min. If this is your first time doing R, yes, it could be very easy to copy and paste, but I encourage you to type it out to avoid any syntax errors. And that way, you can get the bottom 10, which has a lot more rows because there's a lot more storms that, overlap and tie for the bottom 10. So we can see the year, the wind speed's a lot lower, and the status. So we have gotten a glimpse at the lowest magnitude storms based on wind speed, that is, not necessarily damage. All right, so that's slice max and slice min. The slice function continues to go forward. And let's say you want to just, since we know there's 10,000 rows, if we want a glimpse at the first 5, we want to use slice head. So kind of like your body, the head is the top, your feet or your tail end is the bottom. Touch on tail momentarily. So we use slice head. We're using the data set storms, and we want to just look at the top 5. Again, you can do top 10, top 100 rows, but for this, we're just going to do 5. Slice head storms n equals 5. So we're just going to see 1, 2, 3, 4, 5. They're all named Amy, all in the same year. So it's probably duplicate data sets just based on the measurements they collected, or it's over the course of the days and the hours. So we can see why it's still all named Amy, because they're making measurements on a 6-hour basis over a 24-hour period. So that's why it goes from day 27 to day 28. We can see the category and the wind speed. So quite a low wind speed, but we're looking at the head of the data set, the top 5. So if we want to say top 10, let's see what happens. Still all named Amy because this looks like a multi-day storm in the year 1975, but we see 10 rows and only 10 rows. Now, if we want to look at the last 5 rows of the data set, we use slice tail. Same thing. We're seeing the lowest 5. And I'm guessing they're organized by year in the data set because we're now in the year 2015. We see 5 rows and 13 columns. So that's a quick and effective way of looking at the top of the data sheet and the bottom of the data sheet before you really decide how you want to parse apart your data. Now, please note, there are other functions within Slice, but I'm only going to show these 4 examples. So if you want to go further into this function, I will put the link in the description to walk you through it further. Now, so far with subsetting, we have been subsetting by row, but what if you want to subset by the column? By using the select function, we open up a number of possibilities with our data to select columns by name or another function. For instance, now we're going back to the iris data set. And we use the select function, so we're going to select from the data set iris, sepal width, petal length, and species. And if we look at the iris data set briefly, we know there's much more than just sepal width, petal length, and species. We know there's sepal length and petal length. But since we only indicate we want these 3 columns, we only get the output of these 3 columns. Now, within select, there's a bunch of helper functions that allows us to subset with greater specificity. We can select columns with names consisting of specific character strings in it. So if you only want to isolate, say, sepal, you can do that. So, but for the first example, we're going to select by a general character, because between sepal length, sepal width, petal length, petal width, there's a period. So selecting iris that contains, and then in quotations, a period, we're going to see 4 of the 5 columns because species does not have a period in it. See here, petal dot width, petal dot length, sepal dot width, sepal dot length. And that's because we specified we want all the columns that contain that character. Now, if we want the columns that just contain sepal, you get 2 columns, which is accurately represented in the iris dataset as a whole. And you can adjust this to your own dataset as well. So if you're only looking to pull out certain amounts of data, this is a very good function. And now we're getting to the nitty-gritty of select. We can select columns whose name ends with a character string of our choice. In this case, we're going to look at the columns that end with length. So rather than contains, we put ends with length. Sepal length, petal length. And we know that is accurately represented in the iris data set. Additionally, we can select all columns. So say you want to see everything. Select iris, comma, everything. And we get the output 1, 2, 3, 4, 5 columns, 150 rows. If we look at the iris data set, we know there are 5 columns and 150 rows. I can't stress enough how important these quotations are. Without it, you will not get the output you want. You'll get an error. So let's say if you want to select columns whose name matches a regular expression, select iris matches dot t. We're basically looking for any column that has the letter T in it. Moving forward, select columns whose names are in a group of names. Now we know the iris doesn't have a genus column, but let's say you did have a genus column. You could select iris and selecting one of this list. C, this letter C here allows you to create a list of syntax within the function of one of. So selecting iris, one of either species or genus, and you run this function, you see that we only have species. Now let's select columns whose names start with a character string. So we're going to touch on starts with. Earlier we did ends with. So whereas before we looked at ends with length, now let's say we want to isolate it starts with the word sepal. Select from the dataset iris starts with quotes sepal. We're going to see, you guessed it, 2 columns, sepal length and sepal width. Now, let's say you have X amount of columns on the front of your data sheet that you want to not use or not look at? Well, you can designate a range of columns you want to see using the colon symbol. So select iris, and we're going to look at all the columns between sepal length and petal width. So let's look at this real quick. Sepal length and petal width. And because we did that, we're looking at the columns between. So sepal length on the left, and that's important that it's on the left because it comes before petal width. So sepal length to petal width. We've indicated that range here. If we run it, we get sepal length to petal width. If we put sepal width to say species, you'll notice that sepal length disappears. Sepal width, petal length, petal width, species. This is a very powerful function for you to subset your data based on a column. Lastly, what if you want to omit a certain column and you want everything else and you're only looking to remove one? So in this instance, we're selecting columns except for species. The negative sign indicates we will exclude it from our output. Select iris, negative species. Length, width, petal length, petal width. We can try this again with a different column. Choose your own. I encourage you to do so, or you can follow along with me. Let's do sepal width, something that's in the middle. Sepal length, petal width, and species. It's quite simple. So we're going to take another pause here before we move on to reshaping our data. This was a lot in this section of the video, so I encourage you to go back and work on these slice functions, filter functions, and select functions. Okay, now we're going to be moving into how we can reshape our data. So say you need to combine columns, separate them, spread them, arrange them, etc. We're going to go through that. So we're going to be using a pre-loaded data set that should be openly available called Table 1. And this is what it looks like. We have columns country, year, cases, and population. We'll be touching on some iterations of this table and subsequent lines of this script. Now, let's say you want to gather a couple columns and combine them into one column. So using what we went through before, we're going to touch on piping for ease of understanding of what we are doing. So with table 1 being the data frame, we want to gather. So if you have a mess on your table and you wrap your arms around it and pull it towards yourself, you're gathering it. So here we are gathering 2 columns in table 1. And we want to call them key value. And we're depicting the range of columns that we're touching on. So 2 and 3. See that? Columns 2 to 3. We want to gather them, year and cases. And this first word, key, will be one column combining both year and cases. So it'll say year, 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 cases, cases, so on. And then the next column will be the value that is found. So that'll be the numbers that are listed for both year and cases. So we're going to have 2 columns, but we're combining year and cases. So what does that look like? What we see below is we have country, population, and key. We just changed it to key. And as I mentioned, it's going to have year and cases in the same column rather than them being independent of each other. And then the value column combines the year and the number of cases. So probably not incredibly useful for this particular data set, but maybe it will work for yours. And if you need to combine things, maybe it was year and month and hour and day, and you wanted to parse apart your data, you could combine them all into one column. So the year, month, day, hour, so on. And then the values would be provided, and then you can plot that across a series of figures. Now that we have key and value listed in two separate columns, maybe we started this way and we want to separate them once again. So we want to have a singular column titled year and a singular column titled cases. So we just gathered those. And if we want to separate them, we want to spread them back out, hence the spread function. Now I've commented this out in order for this to work, but we can just add another pipe to this. So we've gathered them and we've just shown what that looks like. Now we can spread them apart again. So what we have here is we're piping into the next thing. So we're spreading the two columns, key and value. So we want to separate key and value into their independent cases and years, and then those values that are listed. So what does that look like now? As you just saw below, we have cases reinstated as its own column, and we have year reinstated as its own column, and the values are now associated side by side in two separate columns rather than in one singular column. So gather and spread work very well together. Now, we're going to move into the separate and unite function, but this is where we're going to look at table 5. So if you view table 5, we can see it's very similar. We have country, century, year, and the rate. And as you see, rate is what I want you to focus on looking at here. So we have a forward slash between a value and another value. And if you look at table 1, we can see those values represent cases and population. And we're going to emulate that in table 5 because they've combined them as a rate. So 745 cases per said population and so forth. So if we want to separate the rate, we're going to do table 5 pipe. So in table 5, we want to separate the rate. And now we need to list the new columns that we want it to be listed as. So C, and then in quotations, because unlike before, you need to create and name those two new columns. So we want to make it cases and population, and that'll have an output as such. So as we see up here, rate is 745 per population, and what we just created here is 745 under the cases column per the population in its own separate column. So it actually knows to split the data at that forward slash, which is quite smart and efficient. Now let's say we want to go from these two separate columns and combine them into the rate. Well, we're going to use the unite function. We can do that by creating another pipe. So we have separated these data sets. Now we're uniting them into one column. So we're creating the column rate, and we need to combine or unite columns 4 and 5. 1, 2, 3, see 4 and 5 are what we're combining into one column titled rate. It gets rid of cases and population. It doesn't have the forward slash as before. However, you have an underscore to separate those values. So 745 per the population. So that's separate and unite. These are excellent ways to reshape your data. Now, I know I'm throwing a lot at you and telling you to look at various data sets that are in R. We're moving forward into another one again. We're going to go to MT cars. What is that one? If you've not been familiarized with it, it shows various car models, MPG cycles, and so on. This is an excellent data set that you'll find many tutorials using. So we can order our rows by values of a column from low to high. So let's say we want to arrange by a singular column. You can do that by using the arrange function. So if we arrange MT cars by MPG, so MPG is the column, and if we're going to arrange it, we're going to see the output showing it from low to high. And you can see MPG being listed from low to high. Similarly, if you just click on the column in your data set here, it does that for you as well. But if you need to do it in a function this way, in your script, that is also available. And let's say you want to arrange it from high to low, you just add descending or DESC into the function. So same script, I encourage you to type it out, arrange our data. The data is MT cars. And we want it in descending order, and we want to use the column MPG. So now we can see it's going in descending order. Just a very simple method to look at your data in ascending or descending order. Now here we're jumping back to the storms data set for renaming a column. So let's say you have a column and you want to just simplify it from a long amount of text to a short amount of text. You can do that with Dplyr using the rename function. And in this instance, we're going to go from the column year, we want to name Y, just to signify it in a more simplified manner. So rename in the dataset storms, we want Y to be the column year. And as you see, Y has now replaced year, and month and day and hour and lat. So let's say we also want to do that. Rename storms. Let's say month is M. It just changed it to M. So that is a way to reshape your data. And moving forward, we're going to touch on summarizing your data. So we're going to take a brief pause here, run through this again, understand the script, and we'll come back and use the summarize function. Okay, now we're going to move into the summarize function within Dplyr. And this, as you would expect it to, allows you to quickly summarize aspects of your data. So going back primarily to the iris data set for this section, we're going to run through this. So typing in summarize with the data set iris, because that's what we want to summarize. Average is what we're wanting the quote unquote output to say. Average is equal to the mean, and in this instance, we're looking at sepal length. You can do petal length if you would like as well, but it needs to be numerical in order for it to output the mean of said variable. So summarize, and we're finding the average, and you can see below that the average sepal length is 5.84, whatever units that they chose. You can do the same with your own personal data. All right, if we want to summarize a bunch of things, you do iris, funds, mean. We run that through, and we can see that gives us the average or the mean of all of our variables. CS species says NA because it's not a numeric column. It has syntax, but we can therefore go across and find that sepal length is 5.84, width 3.05, petal length 3.75, petal width 1.19. So that's a way to get the mean across your entire data set. So if you need to do a quick summary, I would suggest using that. If you need a targeted summary, use the prior line. If you are getting a data set from someone else and you're unsure of how many items are in it, you can do a count function. Count from the data set, iris. We're counting species, and we're weighting it off of sepal length. So we're counting and more or less summarizing for iris setosa. This is the total sum of sepal length. For versicolor, it's the total sum. And for virginica, it's the total sum of the sepal length. So that's a quick way to, if you have multiple, say, species, and you want to get a gross weight of their entirety, that's a way you can do it. Moving forward, we're going to do some very quick, simple methods within summarize. Maybe you want to see what's first in the iris data set. We run that, and it starts from the top. So if you go to the data set, iris, 5.1, 4.9, 4.7. And you see down here in the console, 5.1, 4.9, 4.7. And so on and so forth, all the way through all of the variables listed. If you want to look at it the other way, you can do last iris. And why is it going to the species column? That's because it's in summarize function. It looks at first and last as first column and last column based on its order. Which brings us to this next one. How would you isolate and look at the order of a different column in between first and last? That's where nth comes in. The nth column. In this instance, I chose 2. In which is sepal width 3.5, 3.0, 3.2. So n iris 2 gives us in the console below those measurements for the second column. If we did the third column, it would do the third column's values. This is probably a bit more powerful than the prior two, as you're able to isolate a particular column of your desire. Now let's say you want to do some numerical, mathematical calculations quickly in R. You can do min, max, mean, median, the variation, standard deviation. So min, and here's the other thing that we need to take note on. I put the $sign in, because if you do min and just iris, it's not going to know which of those columns you're trying to summarize. So by targeting the specific sepal length, and you can, if you want to, go choose a different one. But the minimum for sepal length in the iris data set is 4.3. The maximum of the sepal length in the iris data set is 7.9. What's the average? Well, we did that earlier, so 5.84. What's the exact middle? The median. Again, iris, $sign, sepal length, 5.8. What's the variability? 0.68. And what's the standard deviation? 0.82. Now, there are other ways you can go about looking at your data mathematically and getting these functions out. This is the primary way to do it across most of your calculations you might do in R. So I suggest you keep this down and ready to go, as this is very frequent and common if you're beginning to parse apart your data. if you want to know how many distinct items there are within your data set, and that way you can maybe understand how many duplicates there might be. Say you're looking at microbial taxa, you want to know how many distinct members there are, you'd probably run n distinct. That means there are no duplicates. So here, n distinct, 149 of them are distinct out of, say, 150. So that likely means there's one duplicate across the entire data set. And then lastly, in the summarize section of this tutorial, maybe you want to just know how many there are total. Summarize iris, how many are there? N is 150. N means the sample number. All right, so that concludes the summarize section. Run through that. If you have your own data set, now would be a good time to try that out. Next, we're going to move on to making new variables. Okay, now on to making new variables in Dplyr. So if you want to sum multiple columns, you can create a new column with the mutate function, and that'll make the calculation you want to carry out. So we have mutate. We want to mutate the data set iris. The new column will be called sepal because we're going to add together both sepal length and sepal width. And if we go down below, we can see that sepal length and sepal width have combined into a column called sepal. And you see that they have been added together in this column. We can mutate each by a minimum rank. And we can see it's been ranking them within their columns based on the species. And if you want to compute one or more new columns and drop the original column, use transmute. So this means, as before, we're creating a column sepal by combining sepal length and sepal width. But now we're going to not be able to see sepal length and sepal width any longer by transmuting it. We will have the column sepal, but not the other two. So if you're doing a quick combine and you don't need that data seen, there, we've isolated it, and there it is by itself. And don't fear, if you're doing this within R, your original data set will still show all the data. It's not as if you're permanently changing your data. And if you happen to freak out, close R, reopen, and reload the data set. Mutate uses window functions. These functions take a vector of values and return another vector of values, such as lead iris. And this will copy values shifted by 1. We can do lag iris, which will copy with values lagged by 1. We can do a density rank, ranks with no gaps between data, but this you need to have a specific column in mind. We can do a minimum rank. We can do a percent rank, which are rescaled from 0 to 1. We can do a row number. And you can see down here in the terminal, or the console, excuse me, you have row numbers for specific items based on their rank. Additionally, we have the ntile function. It is the only Dplyr ranking function which takes 2 arguments as input, the input vector and an integer, which is defining the number of groups to split up into. So if we want to split up iris into 600 groups, we do ntile and 6 iris and 600. Now, let's say you want to know how many values lie within a range, because you might already know what's outside the reasonable range for your data, so you want to narrow it down fast. You can use the between function. I chose between 1 and 5 for sepal length because it's a bit more arbitrary. Know your upper and lower limits of your own data, and between can be a very helpful tool. It reports a true false value though, so it'll show you if this value of sepal length is between 1 and 5. False if it's not, true if it is. Cum_dist is the cumulative distribution function, which returns the proportion of all values less than or equal to the current rank. Cum_all is the cumulative of all. Cum_any looks at any of them. Cum_mean is the function that calculates the mean of measurements as the values add up from the top of the column through the bottom. Therefore, the mean changes. So you can see early on it's 5.1. It lowers as you have the mean values of sepal length change, and then it might increase. So as you accumulate down the rows of data, that mean will change because it's adding one by one, row by row. Cum_sum, this function adds up each row on top of each other cumulatively. So you, again, 5.1, 10, 14, and so on all the way up to 876.5. Cum_max function creates an output of the maximum number in a column that overwrites any value less than it. So if the first value is higher than the second, it'll overwrite it. So you can see it's kind of a battle. 5.1, 5.1, oh, and then 5.4 is bigger than 5.1, so it changes, and then we end up with 7.9 whenever that came about in whichever row. Cum_min does the opposite. It replaces the larger value with the smaller one. Cumulative production. Pmax. Pmin. Again, the data sheet, the cheat sheet will be attached below, but for time's sake as well, we're going to go into group data. Mind you, I'm also showing you mostly every facet of this cheat sheet. That does not mean you're going to use all of these regularly. So on to group data. This is going to be a shorter section, and then the final one is combined data sets, which will be more of a discussion. So grouping data, you'll be able to group your data. And for this instance, we're grouping by, in the data set iris, grouping by species. Setosa, till you keep going on, versicolor, and so on. Virginica. If you want to ungroup it, you run ungroup iris. And now it might be back to its original randomization. However, the data set itself was not that randomized. So the group function is very helpful if you need to have an overarching view of what your data is. If it's been jumbled, it'll help you sort by a specific column. So maybe you group by treatment. Now we're going to go to a summarize function within group data, which computes separate summary row for each group. And now we're using pipes. So iris, pipe to group by species. So we're first grouping by species, and then we're going to summarize the mean of sepal width by species. So as you can see, it's grouped by the species, and then it's summarizing the mean of sepal width. We only get 3 values because there's only 3 species, and there's your overall average. Very quick, very effective. Now, if we want to compute new variables by group, we use mutate. Again, this is similar to the mutate function as before. We're just piping it in, so it's a subset of another thing. So iris, we're starting with the iris data set. Within the iris data set, we're grouping by species. And then within species, we want to mutate species. And we're going to create that extra column, sepal, again, as before, which is an addition of sepal length and sepal width. So you can see here, it's going to group by species, and we're going to have that combination. So does it really do that much different than what we did earlier? Not really. Can it be effective? Yes. There's always more than one way to do things in R. And this brings us to combine data sets. So this is more of a discussion piece because it's not too pertinent to run through specific data sets in R. So I'd rather you look at this sheet and understand it than have me show you some arbitrary data that is not open source. So combining data sets. Dplyr has a left join function, which will put in the order that you select, we're going to combine A and B. A being the first, B being the second. Left joining means B is going to attach to A. So you can see here in this example that B by X1 has attached. Since A, B, D is already there, we have A, B, C. C is not existent in B, so it's NA. It'll have another row that'll say D, and it'll be NA, and then a value. If you want to go from A into B, you right join AB by X1. So again, there you have ABD, the other column for B, and then you can see that X2 is the other column from A being appended to B. You also have inner join. Join data, retain only rows within both sets. So because C is non-existent in B and D is non-existent in A, you only get A and B values. So that's an inner join. So maybe you want to find common values between, say, microbial communities from different sampling sites, and you want to see how much overlap there is. Inner join would be a really effective way to look at that. Full join, joining data, retain all values in all rows. Again, D exists, C exists. We have NAs in there. But it's important to know full join, you start with A, then B, and by whatever column you want to attach it to. You can filter joins. You can do a semi-join, AB by X1, all rows in A that have a match in B. So it's similar to inner join, a little bit different, but similar. And you can do anti-join, AB by X1, all rows in A that do not have a match in B. You could conversely do it B comma A by X1, and then this would say D and true. We can do intersect, Y, Z, rows that appear in both Y and Z. So you're going to intersect them. Union, you could join them together, so you can see D is being added to the bottom. Set difference, rows that appear in Y but not Z. And then lastly, binding. You can bind rows, append Z to Y as new rows. So maybe you have two data sets that have exact same treatments, they're just in two documents, or maybe you were handed data that's very similar and you need to make a master data sheet. Boom, bind rows, append Z to Y as new rows. Same thing with columns. Maybe it's a very large data sheet, append Z to Y as new columns. But do know that matches rows by position. So Dplyr is a very powerful tool. It's a very effective tool. One of the most used packages in RStudio. Again, I will attach the Dplyr cheat sheet below in the description. If you have questions, please ask. I appreciate you making it this far into the video. All right.